All right, we've talked a lot about incremental sampling and in a general context and even diagrammed a little bit. Now we're going to look at it in a very brief format, but it'll hopefully give you some idea beyond what we've talked about already. As you can see, it's a little complicated conceptually, but it's not that bad, and it's a really good thing. Some of these slides are kind of repeats, so we'll go through them fairly quickly. Again, this was originated in the mining industry where we had lots of heterogeneity, but we also have that here in the environmental world. Core material, we've seen this slide, can be very heterogeneous, and deciding where to sample and what is a sample. Now that we can ask that question and have one common mind about what the problem is of defining a sample. We asked that yesterday, what is a sample within this distance, or what really is appropriate for our use. Okay. According to Piaget's sampling theory, we're looking for trace particles below 1 part per million, 10,000, 1%. And the population is the whole, in this case something not too big. We have a sample defined as something small here, something larger here. You can see again, no particles. Here we get particles. That's more representative of this whole population. And so if we do get that hot particle, then we get a fairly high concentration, whereas that's a lot higher than the average concentration. And so again, the support size is not always representative of the volume. And that's our challenge, is to make it so to the extent possible with enough increments and enough samples. G sampling theory integrates and emphasizes grouping and segregation. One more time, grouping is where particles cluster into little groups like this throughout the overall. Segregation is where you have more of a massive exodus or segregation, whether either on top from the large particles coming up or other particles going to the bottom. This could be a density issue. We have this, of course, in gold, or if you have lead. Side issue, a scoop has to be designed correctly for the increments. We talked about that in the Japanese slab cake exercise. Okay, here are the most difficult, the iconic ones. Again, we had autofluff, we have explosives, pretty good sized nugget in the soil, and then PCBs are also very heterogeneous. Here we have our two founders of incremental sampling, Petard and Piaget. So what exactly is incremental sampling? And here I've provided a definition. This comes from the ITRC guidance document, as we see here. This was put out, I think, in either 2010, 2012. I have a copy if you need one. Otherwise, just Google it, ITRC incremental sampling. You should be able to find it quite easily. It's pretty thick, but it's pretty comprehensive. It's a pretty good document. We'll see a few things from that today that are actually in the white paper too. Basically, it is a structured sampling protocol for representative and reproducible sampling of a well-defined soil area or volume, i.e. decision unit, to obtain a concentration value representative of the average concentration over the entire decision unit. All right, there's a lot in here. First thing, it's structured, okay? This goes back to the DQOs. This is part of a systematic, structured process to get the quality and quantity of data that we need. And as we could see from our little chart over here, there's a lot of structure there, no matter how we decide to structure it. And there's lots of different ways. We want samples that are representative and reproducible. And if we do incremental sampling correctly, according to the theory by the central limit theorem, the three, say, incremental samples we take at a site, composed of 30 or more increments, those are representing an average. So they should be not only close to the true average, they should also be close to each other, because if they're close to the true, they themselves should be close. If they're not, sends up a little warning flag, but that's the goal. So when we go back to the definition, that gives us some guidance as to how we analyze what we get. And again, I kind of missed this one. It is a protocol that we develop, individual, through DQOs at every situation, for every pile, every site. Now, it stresses well-defined soil area or volume, a decision unit. Support, support, support. So, ITRC is echoing what, I'm trying to maybe overkill, drive into your heads today. Support volume, decision unit is very, very important. That concentration needs to be representative of the average. We'll talk about this in incremental sampling. An average is a really good target or objective or statistic. It's not always the one you want, but for pile sampling, it's probably going to be a very good one. And that's going to represent the entire volume. Okay? We'll also talk about sampling units, which are a little bit of a subset. And those can be a little confusing, but in the end, we make a decision on one volume, whatever that is determined to be. So there's a lot, and I think they did a good job with this definition. Now, it's kind of a mantra in the DQO world that heterogeneity rules and support rules, and here we have decision units rule. That's our ultimate